I'm Bruce Fouke from the University of Illinois Urbana-Champaign. The rise of the mammals wasn't just coincidence. It was an Earth that was ready to have a new breed, a new type of very diverse, sophisticated, and capable set of organisms evolve and radiate into new Earth ecospace that was opened up dramatically by the KT impact at 65.5 million years before present. So let's look at the history from the KT impact to the modern as a broad brush overview of what the Earth was like at that time period. The place to start that I think is really, really important here is the idea that the Earth was extremely warm in the age of the dinosaurs. So as you can see in this diagram, if you go at the left-hand side, you'll see the vertical axis, the y-axis is temperature and the x-axis is time, that the average temperatures of the Earth at the time of the dinosaurs were approaching 26 to 29 degrees Celsius. Now that is fully another 10 to 15 degrees Celsius warmer than what it is in the modern day Earth. So the average temperature of the modern day Earth is approximately 14 degrees Celsius. So the Earth was a very warm place. And one of the things to keep in mind when you take a look at the concepts of a modern day warming Earth, it's not the question of magnitude or how much warming is taking place, because we've had an Earth that was a lot warmer than it is now, and we've had an Earth that was a lot colder. We had ice sheets even at the equators. So it's not the magnitude or the amount of warming, it's the rate over which the warming is taking place. And I think that's really well emphasized by taking a look at a graphic like this of how warm the Earth used to be, especially in the age of the dinosaurs. Well, coming off the KT impact, the Earth cooled a little bit, but not much, went back up and hit another high at the end of the Paleogene, and then the Earth started a dramatic history of cooling, which we are still a part of. And you can see then the rapid drop in temperature as we move into the Eocene. Now, the Eocene is marked by another fundamentally critical event in Earth history, and that was the rise and the development of the Antarctic ice sheet. So from the age of the dinosaurs in the Cretaceous through the Eocene, it was a planet without ice sheets. And then the Earth cooled again to the point where ice could be developed on the poles. So the onset of Antarctic glaciation in the Eocene, nicely shown on this diagram. And from that Eocene time period, then we've seen an Earth where the relative rates of some of the warming and the cooling have increased, but not nearly as rapidly as what we're seeing in the modern day Earth. Over the last 100 years, the average rise in Earth temperature has been about 1 degree Celsius. But from about 2000 up into 2100, the estimates are that the rise in Earth temperature could be as great as 8 degrees Celsius over 100 years. And 8 degrees Celsius is dramatically steeper and faster than any of the types of temperature rises or drops that we see on these diagrams. Well, as we go from the Eocene, now we're into a glacially dominated Earth. We have rises and falls with an overall drop in temperature, especially after we reach the end of the Oligocene and into the Miocene. And so those drops continue until we get into the age of the ice, or the ice ages in the Pleistocene. So in the lower right-hand part of this diagram, you'll see we move into the glacial episodes with high frequency, in a relative sense, change in temperature, but nothing even close to what we're recording in modern day Earth. So this is the template we need to remember, an incredibly warmer Earth at the age of the dinosaurs. The KT impact opening up ecosystem space both in the terrestrial and marine environments, and then a slow trend toward cooling, then the onset of the Antarctic glacial sheets, and then moving fully into the age of the ice. And so we are now coming out of the most recent cold time period on planet Earth, and then tracking the advance and the acceleration in warming as we move up into the modern. So this template of a warm Earth that's cooling, that's going into then a high frequency changing Earth of temperature, is the template over which especially the mammals have evolved. And that will be the stage on which we'll evaluate mammalian evolution throughout the Cenozoic.